Good morning, good afternoon, and good evening. Today we are going to be comparing and ordering decimals. We're going to do that in a couple of ways, two ways actually, and we're going to be using number lines and place value charts. So before we get into decimals, let's just take a look at some ways that we already compare whole numbers or numbers that are greater, that are one and greater. So we are talking about ways to compare them, and the ways that we do compare them are one with a number line. So we can make any number line, say this is 1 and this is 10. We could put 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we can say that we want to figure out the number 2 and the number 4, and which is greater. The number that is further away from 0, so 0 being here, is going to be the greater number. And so you can see here that 2 would be less than 4 because 4 is further away from 0. Okay? So that would be whole numbers. Another way that we compare numbers is using place value. So let's dive into a larger number here. Let's dive into 3,628, and let's dive into 3,632. And oftentimes you're given two numbers to compare, and they are side by side like this. The strategy is to stack the numbers on top of each other, just like we do in number one with mountain math. So 3,632. Now they're stacked, and now we can clearly compare these two numbers. We can use the largest place value position, starting with the largest place value position, moving to the right to the smallest place value position to find the first number, first place value position with a digit that is different. And so we can't use the thousands place. There's a 3 in there in each number. Can't use the hundreds place. There's a 6 in each position. But we can use the tens place. And so all we have to do is look at what is the larger number that sits in the tens place. That'll give you the greatest number. Since the 3 is larger than the 2, 3,628 is less than 3,632. Or if we read it right to left, 3,632 is greater than 3,628. So these are whole numbers. These are numbers that are one and greater. Today, because we're comparing and ordering decimals, we are going to be working with a number line that is between 0 and 1. And that's it. Okay. So now we're dealing with numbers that are smaller than 1, but still greater than 0. And that means that all of the numbers we're working with will not have a number, a digit today in the ones place. And so you're going to see a 0 in the ones place for the numbers that we are comparing today. So let's dive into the lesson, some of the guided practice. So we have, just real quick, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9, and then comes 1. So we're going to be comparing numbers that one have a 0 in the ones place and a decimal either in the tenths or next to the tenths is the hundredths place. And so I just want you to be aware of what kind of numbers we are working with today. Very similar to fractions, like dealing with fractions, you're dealing with numbers that are greater than 0 but less than 1. Hi. Sorry.
Do you want to watch that Justice League movie that you were watching?
Uh-huh.
Is it versus the Fatal Five?
Uh-uh. It's called Dark.
Justice League Dark.
Uh-huh. Sorry for the interruption there, kids. Mommy will find it. So, all the numbers that we're working with are greater than 0, but less than 1. Okay. The guided practice of this lesson gives us plenty of problems to work that out. So not only are we going to be comparing, but we're going to be ordering them. So the first two numbers that we are going to compare are 2/10 and 6/10, right? So take a look at our number line. We have 2/10 and we have 6/10. And remember what I said up here. I said that the number that is further away from 0 is going to be the greatest number. And so if we have 2/10 and 6/10, we can see that the 6 is further away from the 0, making 6/10 greater than 2/10. Okay? Another way for us to look at that is stacking the numbers, or writing the sentence down, 0.2 or 2/10, and then you have 0.6 or 6/10. So we want to stack these two numbers on top of each other, and we want to find the place value position that we can use to compare these numbers. Well, like I said, we're going to have zeros in the ones place, so we can't use the ones place, but we can use the tenths place. Okay. And so we have a 2 and a 6. That 6 is greater than the 2, which makes 2/10 less than 6/10, or reading right to left, 6/10 is greater than 2/10. And we can go in and we can put in our appropriate sign. Now we have 4/10 and 4/100. Now, 4/100, check this out. 4/100 is super tiny. 4/100 is less than 1/10. Okay, so why is that? Okay, so we are dealing with between 0 and 1/10, not even between 0 and 1. Okay, so 4/100 is way inside of here between 0 and 1/10. And then our second number, or first number, would be 4/10. So we have 4/10, and then we have 4/100, which is tucked in way over here, less than 1/10. And I know that because when I write 4/100, that's how I write 4/100. There's nothing in the tenths place, but there is a digit, the 4 in the hundredths place. And then you have 0.4, or 4/10. Okay, and you, of course, you can add a 0 there as a place value holder. Also letting you know that 4/10 is equivalent to 40/100. So in comparing these numbers, we're going to use the tenths place. Because there's a 0 in the tenths place in 4/100 and a 4 in the tenths place in 4/10, 4/100 is less than 4/10. Okay, so stacking these numbers on top of each other is going to be a huge help. But also understanding that when you have a 0 in the tenths place, that puts that number less than 1/10. Okay, so I just want you to be aware of that. Okay, let's look at the appropriate problem here. 4/10 is greater than 4/100. Here we have 6/10 and 60/100. Let's take a look at that. Here we have 6/10, but where's 60/100? Well, let's take a look here. 0.6 for 6/10 and 0.60 for 60/100. Now, I want you to understand that what I just did over here for problem number 2, when I put 0.4, okay, which is the number that is in number 2, I added this 0 as a place value holder. That changed the decimal to 40/100. 40/100 is equivalent or the same as 4/10. And that goes back to our lesson a few days ago. when we were looking at 7/10 or 70/100, right? 7/10 or 70/100, they are equivalent because if I cross off 7 of these 10 bars, right? I could easily change this to hundreds simply by putting 10 smaller boxes into each one of these bars. And now all of a sudden, I don't just have 7 bars, I have 70 little boxes, 70/100s colored all the way through this little chart. Okay? So 70/100s is the same as 7/10. Okay? Just like 40/100s is the same as 4/10. And I just dropped my pen, so I need to pick it up. All right. So let us take a look at the next problem. Oh, no. Let us compare 6/10 and 60/100s. That's where I was at. Can't use the ones place. There's a 0 in the ones place. But we can use the 6 in the 10. We could use the tens place. Why? I know there's the same number. Guys, you could keep adding zeros and zeros and zeros to the end of time, right? But no matter what, these two numbers are equivalent. Okay? All right. So now we have 57/100, okay? And we have 7/10. 57/100 sits somewhere over here, close to 6/10, right? 57/100, okay, versus 7/10, okay? We can't use the ones place to compare these two numbers, but the first place value position that we come to that has different digits is the tenths place. That 7 is greater. 7/10, here it is on the number line, is greater than 57/100, which sits somewhere just before the 6/10. Okay? 57/100 is less than 7/10. Right? Okay. Now we are assigned the task of ordering numbers from greatest to least. Please start by underlining these directions. Hardest part about ordering numbers from least to greatest, greatest to least, is following the directions. And paying attention, do you need the bigger number first or the smallest number first? So let's look at 2/10, 2/100, and 4/10. 2/10, 4/100, and 4/10. So here we have 3 numbers that we need to order greatest to least. What am I going to do? I'm going to stack these numbers on top of each other. 0.04, and then we have 0.4. So here's our 3 numbers. I just moved them so that I could stack them and see the place value positions very, very clearly. I see that 2/10, okay, or the tenths place is the position that I'm going to use. I have a 2, I have a 0, and I have a 4. Well, the biggest of those, as I begin ordering these greatest to least, is the 4. So 4/10 will come first, then the 2 is larger than the 0, 2/10 will come second, and that 0, or 4/100 sits right there, okay? Correct. So let's look at why is 4/100 smaller than 4/10. And I'm going to do that by drawing these squares. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I'll draw another one. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Here, I'm going to color in 4/10. So 1/10, 2/10, 3/10, and 4/10. That's 4/10. See, now I need to color in 4 100ths. How do I do that? Well, assuming that 1, 2, 3, 4, and I'm changing these tenths to hundreds simply by drawing little boxes, 10 of them in each one of the 10 bars. 4, 5, 6, 7, 8, and 9. Okay, now I got hundreds, right? Simply because now I have 10 boxes in each one of my 10 bars. Okay, and now I'm going to color 4 100ths. 1, 2, 3, and 4. Why is 4/10 greater than 4 100ths? Because 4 100ths only colors 4 of the tiny boxes within one of those 10 bars, and 4/10 is 4 whole bars, or 40 100ths if I had 10 little boxes in each side of these, inside of each one of those 10 bars. Okay, so that's why 4/10 is greater than 4 100ths. 0.4, 0.2, excuse me, 0.4, 0.2, and then 0.02, or 2 100ths. Okay, let's look at the last guided practice problem here. 51 100ths, 34 100ths, and 46 100ths. 51, 34, 46. 51, 34, and 46. In the appropriate decimal, I can put the 0 in the ones place, because again, we're not dealing with any numbers that are 1 or greater today. So now all we have to do is, since they're already stacked, what's the greatest number that's in the first place value position that has different digits? 5, 3, and 4. So greatest to least, 51 100ths, which would be 5 of these 10 bars colored in with one little tiny square colored in. Then we have 46, because the 4 is greater than the 3, 100ths. And then the 3 is the smallest, 34 100ths. Okay, so 51 100ths would be these 5 of these 10 bars colored with one little box colored. 34 100ths would be 3 of these bars colored in with 4 of the hundredths boxes, okay, colored in. And then 46 would be 1, 2, 3, 4 of these bars completely colored in with 1, 2, 3, 4, 5, 6 of the 10th 100th boxes colored in the fifth 10 bar. So that is comparing decimals. That is ordering the decimals by following directions, greatest to least or least to greatest. You are going to be asked on your independent practice or your homework page to use a number line to check your work. For example, you have a number line and go back to that initial direction that I was saying. Okay, draw a number line that's a 0 to 1. Okay, we are not dealing with numbers greater than 1 today. 0 all the way to 1. You have 1/10, 2/10, 3/10, 4, 5, 6, 7, 8, and 9/10, and you can see that 5/10 is less than 7/10 because 7/10 is further away from the 0. And that's drawing a number line to check your work right there. All right, boys and girls, comparing and ordering decimals, just make sure that you follow directions. And of course, as always, send emails, dojo messages, letting me know if you have any questions. All right, you guys take care.